Welcome to another session of Grade 9 Mathematics, Chapter 7 Triangles. Dear students, in this part of the chapter, we shall discuss in detail the solutions to NCERT Exercise 7.1. Let us quickly get into the first question of NCERT Exercise 7.1. Question number 1. It says that in quadrilateral ACBD, AC is equal to AD and AB bisects angle A. See the figure. Let us quickly get to the figure also. Yes, the figure also shows that we have got a quadrilateral ACBD. And it also shows by marking it out that AC and AD are equal. And AB line segment bisects angle A. So what does that mean? That angle CAB and angle DAB would be equal. Now what are we supposed to prove? That triangle ABC is congruent to triangle ABD. And it also asks us to say about BC and BD. Let us quickly get into the solution. My dear students, the very first thing that you have to do is consider those triangles which has to be proved. So here I have been asked to prove triangle ABC to be congruent to triangle ABD. So as you could see in the solution, I have considered those two triangles. Now, in triangle ABC and triangle ABD, we have AC is equal to AD, which is given. I can also write that angle CAB is equal to angle DAB. Why so? Because it is mentioned that AB bisects angle A. Also, if we could consider these two triangles, AB of triangle ABC is equal to the AB of triangle ABD because that's a common side. So, you could see over here that we have got side, angle and a side of triangle ABC equal to side, angle and side of triangle ABD. So with the help of SAS congruency rule, I can state that triangle ABC is congruent to triangle ABD. Now, if triangle ABC is congruent to triangle ABD, I can also conclude that the corresponding parts are equal. Now, what have been asked to say about in the question? Say about BC and BD. Now, if you could see, I have written triangle ABC is congruent to triangle ABD. In that triangle, I can say that BC of triangle ABC is equal to BD of triangle ABD. The reason is CPCT, that is corresponding part of a congruent triangles are equal. I hope the solution to the first question is clear to you all. Now let us get into question number 2. Question number 2 says that ABCD is a quadrilateral in which AD is equal to BC. Let us look into the figure. ABCD is a quadrilateral that is given, and over here it says that AD is equal to BC and angle DAB is equal to angle CBA. A figure is also given. We have been asked to prove first triangle ABD is congruent to triangle BAC. Second, BD is equal to AC. And then third, that angle ABD is equal to angle BAC. Let us quickly get to the solution. Now, as we did with question number 1, here also we'll start with considering the triangles which we need to prove as congruent. But Before that, I'll mention what has been given. In the given figure, ABCD is a quadrilateral in which AD is equal to BC and DAB is equal to CBA. Now, which is the given fact? Now, I'll treat triangle ABD and triangle BAC. Over here, you can see that AD is equal to BC, which is a given factor. Angle DAB of triangle ABD is equal to angle CBA of triangle BAC, which is again a given thing. Also, if we could consider these two triangles, AB of triangle ABD is equal to AB of triangle BAC. Now, we have side, angle and sides of the two triangles equal. So, what can we conclude? We can conclude that triangle ABD is congruent to triangle BAC by SAS congruency rule. Now, what about BD is equal to AC? Yes, BD is equal to AC by CPCT. So the second part of the question is also solved. Similarly, since the two triangles, that is triangle ABD, is congruent to triangle BAC, I can also say that angle ABD is equal to angle BAC. The reason is the same, CPCT, that is corresponding parts of congruent triangle. I hope you are clear with the solution for question number 2. Now let us get into question number 3. Exercise 7.1, question number 3. It says that AD and BC are equal perpendiculars to a line segment AB. So what is equal? AD and BC, they are equal and as well as they are perpendiculars. Let us look into the figure. Yes, it is also mentioned in the figure that AD is equal to BC. And it is also mentioned that angle A and angle B are perpendiculars. Good enough. What have been asked to prove? Show that CD bisects AB. Look into the figure. CD bisects AB. So in other words, can I say that we have been asked to prove that OA is equal to OB, because those are the two equal parts of AB that we shall get when CD bisects AB? Yes. So if we could prove that OA is equal to OB, we can actually prove that CD bisects AB. Now, as from the figure itself, you can see two triangles. Let us start with them. So in triangle AOD and triangle BOC, we have angle AOD is equal to angle BOC. The reason is vertically opposite angles. At the same time, we have angle CBO is equal to angle DAO. It is already given that they are perpendiculars. Hence, each of them will be equal to 90 degrees. Also, it is given that AD is equal to BC. Now, please tell me which rule does it apply over here? It is angle, angle, side. Yes. So I can conclude that angle, angle, side congruency rule helps me to prove over here that triangle AOD is congruent to triangle BOC. Now, once they have been proved as congruent, I can easily tell that AO of triangle AOD is equal to BO of triangle BOC because of CPCT. That is, the corresponding parts of the congruent triangles will be equal. Now, once AO is equal to BO, that directly concludes that CD bisects AB. Hence, we have proved that CD bisects AB. I hope you are clear with the solution for question number 3. Now let us get into question number 4. Question number 4 says that L and M are two parallel lines intersected by another pair of parallel lines P and Q. See figure. Now let us quickly get into the figure. Yes, it is very clearly mentioned that L and M are parallel lines, and through these parallel lines passes another two parallel lines P and Q. Now, what are we asked to prove? We have been asked to prove that triangle ABC is congruent to triangle CDA. You can also look into the figure. Yes, we have got a triangle ABC. We have to prove that this triangle ABC is congruent to another triangle that is given in this part of the figure, that is triangle CDA. Let us quickly get to the solution. Now, in the given figure, ABCD is a parallelogram. Why? Because L and M are parallel lines, hence AD and BC will be parallel. Likewise, P and Q are also parallel lines, hence AB and DC will also be parallel. When I've got both the opposite pair of sides to be parallel, I can easily conclude that ABCD is a parallelogram. And hence, AC becomes the diagonal of my parallelogram. Now, as I could look into the figure, I've got two triangles. Let me consider that. That is triangle ABC and triangle CDA. Now, here I can say that angle BAC, look into the figure, angle BAC is equal to angle DCA. What's the reason? Yes, they are interior alternate angles. Similarly, angle BCA is equal to angle BAC. Again, what's the reason? Yes, they are interior alternate angles. So we have got two angles, corresponding angles of these two triangles equal to one another. What else is equal? Hello, you can see over here that both these two triangles have got a common side, and the common side is AC. So AC of triangle ABC is equal to AC of triangle CDA. Reason? It's a common side. So which rule does come over here? Yes, we have got two angles and a side. But then you observe that the side that is equal, that is AC is equal to another AC of the other triangle, is actually an included side. So I can conclude that triangle ABC is congruent to triangle CDA by ASA congruency rule. I hope you're clear with the solution to this question. If that's the case, let us quickly get to the next question. Exercise 7.1, question number 5. It says that line L is a bisector of angle A. What does bisector mean? Bisector means two equal parts. So line L is the bisector of angle A, and B is any point on L. So if you could look at the figure also, yes, B is a point on the line L. BP and BQ are perpendiculars from B to the arms of angle A. Excellent. It is also given in the figure also that BP and BQ are perpendiculars. So that makes angle Q and angle P to be equal to 90 degrees. What are we supposed to prove? That triangle APB is congruent to triangle AQB. Also, we have been asked to prove that BP is equal to BQ, or in other simple words, B is equidistant from the arms of angle A. Let us quickly get to the solution. Dear students, we'll start with the two triangles that we have to prove as congruent. Let us get to the solution. Now, as mentioned, let's take in triangle APB and triangle AQB. We have angle PAB is equal to angle QAB. Why so? Because line L has bisected angle A in two equal parts. Hence, PAB will be equal to QAB. Also, it is given that angle APB is equal to angle AQB. That is, angle P is equal to angle Q. It is already mentioned that they are perpendiculars. Hence, it is a given factor. Also, if you could observe the figure, there is something common to both the triangles. That is triangle APB and triangle AQB. What is common to both of them? Yes, the side AB. So, over here, I shall conclude that triangle APB is congruent to triangle AQB by AAS congruency rule. I hope that's clear to all. Now, what is the second part that we're supposed to prove? That BP is equal to BQ. That can be easily obtained from the previous step, wherein we have already proved that APB is congruent to AQB. If that's the case, then the corresponding parts are equal. So, hence we can conclude that BP of triangle APB will be equal to BQ of triangle AQB by CPCT, which also means that B is equidistant from the arms of angle A. I hope the solution to this question is pretty clear to everyone. Let us quickly get into the next question. Question number 6, which says, in figure, AC is equal to AE. Let us look into the figure. Yes, it has been given that AC of one triangle is equal to AE of the other triangle. Fine. Also given is that AB is equal to AD. And angle BAD is equal to angle EAC. Okay. Now, what are we supposed to prove? That BC is equal to DE. This seems to be an interesting question. Let's not waste time and quickly get to the solution. Now, let's start with what has been given. We have been given that angle BAD is equal to angle EAC. What I'm going to do next is add angle DAC on both sides. So how shall I write? Angle BAD plus angle DAC will be equal to angle EAC plus angle DAC. Now, if you could look into the figure, angle BAD plus angle DAC together becomes angle BAC. Likewise, on the right hand side, angle EAC plus angle DAC would now become angle EAD. I hope that's clear to all. Okay. Now let us get to the question that we're supposed to prove. We have been asked to prove that BC is equal to DE. Now for that to happen, let me start with two triangles. Triangle ABC and triangle ADE. Now over here, we have that AB is equal to AD, that's given. AC is equal to AE, which is again a given fact. Also, we have just proved that angle BAC is equal to angle DAE. That is the first point. Okay, so what can we conclude? That triangle ABC is congruent to triangle ADE by SAS congruency rule. Okay, please correct over here in the first proof that BAC is equal to actual angle DAE. It's written over here as CAC. Please correct it to BAC is equal to angle DAE. So we have already proved that by SAS congruency rule, triangle ABC is congruent to triangle ADE. Now, if they are congruent triangles, we can easily state that BC is equal to DE. What's the reason? CPCT. That is corresponding parts of congruent triangle. Wasn't this an interesting question? Yes. So now let's quickly get to the next question also. Question number 7. Question number 7 of exercise 6.1, which states that AB is a line segment and P is its midpoint. Let us look into the figure and find where AB is. Yeah, the baseline. So AB is a line segment and P is its midpoint. D and E are points on the same side of AB, such that angle BAD is equal to angle ABE, which is also clearly given in the figure. Also, angle EPA is equal to angle DPB, which is again given in the figure. What are we supposed to prove? That triangle DAP is congruent to triangle EBP. Also, we have been asked to prove that AD is equal to BE. Let us quickly get to the solution and start with the triangles that we have been expected to prove. Now, so in triangle DAP and triangle EBP, can I say that AP is equal to BP? Because it is already given in the question that P is the midpoint. Yes, so AP is equal to BP. Also, what else is given? That angle BAD is equal to angle ABE. Also, angle EPB is equal to angle DPA. Is that clear? Yes. So what I'm going to do next is angle EPA is equal to angle DPB. That means in the next step, what I'm going to do is I'm going to add angle DPE on both the sides. So what would I get? Angle EPA plus angle DPE is equal to angle DPB plus angle DPE. That's how I got angle EPA to be equal to triangle angle DPB. So with these given and proved facts, I can conclude that triangle DPA is congruent to triangle EPB. By which rule? Angle, side, angle, congruency rule. Now, once they are congruent, I'm done with the first part of the question. What is the second part? Yes, we have been asked to prove that AD is equal to BE, which can easily be said by CPCT, that AD is equal to BE. I hope you're all clear with the solution to this question number 7. If yes, let's quickly go to question number 8 and the last question of this session. Exercise 7.1, question number 8. In right angle triangle ABC, right angled at C. So please mention that C is right angled. M is the midpoint of hypotenuse AB. Okay, M is the midpoint of hypotenuse AB. That means AM is equal to BM. C is joined to M and produced to a point D such that DM is equal to CM. Okay, point D is joined to point B and D is then joined to point B. So as you can see, we have been asked to prove 4 things. One is triangle AMC congruent to triangle BMD. The second thing is angle DBC is a right angle. Third is triangle DBC congruent to triangle ACB. Okay, and what's the next thing? That CM is half of AB. Let's quickly get to the solution. Now, as you can see over here, we have started with two triangles. Triangle VND and triangle DMC. It has been given that DM is equal to CM and BM is equal to AM. Yes. How can I say that BM is equal to AM? Yes, the reason is M is the midpoint of AB. Also, you can see that angle DMB will be equal to angle AMC. What's the reason? Yes, vertically opposite angles. Hence, I can say that triangle AMC is congruent to triangle BMD. Which rule? By SAS congruency rule. Hence, the first part of the question is clear. Now, the second part, what we're supposed to prove was that angle DBC is equal to 90 degrees. Now, to prove that, let us try and understand that AC is parallel to BD. AC is parallel to BD. That means angle DBM and angle CAM are alternate angles. Now, also angle DBC plus angle ACB would be equal to 180 degree because these two angles are the co-interior angles of AC parallel to BD. Now, their sum should be 180 degree and they should also be equal to one another. So what does that mean? That angle DBC is also equal to 90 degree because ACB is already 90 degree. Yes, and the total has to be 180. So what does that mean? That angle DBC would be the remaining, which is 90 degree. So we have proved the second part also. Now let us get into the third part of the question, wherein we have been asked to prove that triangle DBC is congruent to triangle ACB. Now, let us consider the two triangles and see what has been given. DB is equal to AC. That is something I can get from the first part of the question, wherein I have already proved that AMC is congruent to BMD. Okay, now that is CPCD for the first part. Now, if you consider these two triangles, BC is a common side. So BC is equal to BC. And if we could say just proved that angle DBC is equal to angle ACB because both of them are equal to 90 degree. So by SAS congruency rule, I can say that triangle DBC is congruent to triangle ACB, which proves my third part of the question also. Let us get into the fourth part of the question. Here I have been asked to prove that CM is half of AB. Now to understand that, let me start with the conclusion of the third part, wherein I have proved that triangle DBC is congruent to triangle ACB. From this, I can conclude that AB of triangle ACB is equal to CD of triangle DBC. If that's the case, if two that things are equal, that is AB is equal to CD, the half of them would also be equal according to Euclid's axiom. And if two things are equal, their halves will also be equal. Therefore, half of AB will be equal to half of CD. So in the last step, what I would write is half of AB is written as it is. But then what is half of CD? It is already given that DM is equal to CM. in the question itself. So half of CD can be written as is equal to DM or is equal to CF. But then I have been asked to prove in the last part that CM is equal to half of AB. I shall write that half of AB is equal to CM instead of DM. With this, we come to the conclusion of question number 8. Also, we come to the conclusion of NCERT exercise 7.1. Dear students, please practice well all these questions of exercise 7.1. The more you practice, the better you'll be able to solve the questions given in the examinations. Practice well. This is all for this part. Take care of yourself until we meet next time with another session. Thank you.